Hello, welcome to Chapter 1, Introduction, in ISO 536, Security Architecture and Design. My name is Dr. Alan Dennis, and I'll be your instructor for this course. Moving straight in to the agenda, first of all, welcome. Welcome to the class, and welcome to our first conversation together. The Chapter 1 covers several things, but it basically introduces the concepts that we'll be talking about through this course. Section 1.1 talks a bit about breach, fix it, so kind of some of the reactionary things that have happened over the years. 1.2 is about information security as it's applied to systems, and then 1.3 is applying security to any system. Over the years, there have been several very high profile sort of negative experiences that have happened in the information technology and information security sort of world. And those things are pretty bad at the time, but out of them, generally good things come. For example, the example there of a password file being stolen off of a website that has, it's basically the source of a 90% of a multi-billion-dollar revenue stream. That's a significant event, and you can bet that the people in charge of that organization took notice. So one of the things that causes these sort of issues is frankly, it's a poor architecture. The term that you'll see on the screen there is spaghetti, and the reason for that is that it's very difficult if you take a plate of spaghetti to tell where one noodle starts and the other ends. The same thing can be true of a lot of the data and control architectures inside of a lot of legacy, certainly applications. So the challenge is not so much necessarily a poor security issue as it is a poor software design and architecture issue. Granted, they kind of go hand in hand, and you can have a very well architected system with very poor security. But if you do have a very well architected system, it's much easier to have a good security model and security controls on place. So continuing that thought, whenever a breach or some negative experience occurs for an organization, that oftentimes is an opportunity to fix things that need fixed. Granted, it's kind of after the fact, which is not ideal, but that oftentimes is what happens. So rather than being proactive and preventing the breaches, a lot of organizations won't pay proper attention to this topic until something really bad has happened. However, there has been a trend lately for organizations to learn from their competitions and other people in their space is mistakes. So if a company witnesses somebody that they view as a peer in their space having something really bad occur, that may be motivation as well. So there's some key concepts that are kind of outlined here, and we'll talk about them more over the course of the term. But sensitive data being in a protected storage and also being protected when in transmission and when in process. So there's some terms around storage at rest, storage in motion, or security at rest, security in motion, or encryption at rest, encryption in motion, and encryption during processing. Those things are actually pretty important topics, and we'll talk more about them over the term. And so taking a look at some of the outcomes that can occur while the initial event is very negative, the overall effect can be positive for an organization if they learn from their mistakes and correct the underlying kind of foundations. Also, if they can do it proactively before bad things happen, so that they start looking at their attack surface and figuring out maybe where they're vulnerable and putting things in place, such as a defense in depth and so on, so that they can avoid it ever occurring. That's even better. So moving into section 1.2, it's good to have some good definitions of what it is that we're talking about, right? So what is security architecture? And what is information security, right? So the ideas here that are kind of underneath of all of the things that you're seeing on the screen is that it needs to be a unified experience. There should be a coordinated sort of design and planning, hence the term architecture, to the entire security systems that are in place inside of an organization. That means that if you didn't have that, the example they have is that firewalls might have no correlation or no interaction with intrusion detection systems. So they wouldn't be able to potentially check things that go together. And antivirus and anti-malware may actually be two different things that don't know about each other, may not have endpoint security in place. So having a unified sort of entirely holistic sort of approach to it is ideal or desirable. And it kind of comes back to you need to understand what it is that the organization needs so that you can facilitate it in a secure and thoughtful way rather than just letting someone like a application developer or an enterprise architect do whatever it is that they feel that they should do. Rather, it needs to be a balancing between the risks that associated with certain activities and the ways that you can mitigate those risks through controls and policies and such. So that's where it's important to make sure that the standards within an organization are unified and uniform and consistent across the entire organization. You want people to feel comfortable and feel secure that someone knows what they're doing, that there is a policy in place that is thought out and holistic and well orchestrated. And if that's not the case, then people stop listening to security personnel. If they don't think that a security person knows what they're doing, they'll potentially ignore the guidance they're receiving, especially if for some reason that security organization isn't empowered so that it can influence, say, the deployment of a system. Then you're basically going to be in a situation where you're just saying things and no one is really listening. Not a desirable situation to be in. It's far better for it to be thoughtful, well respected, and to be viewed not as an adversary inside of the organization, but rather somebody that is worked with to achieve a desired goal of having a secure system and a secure organization and protecting the assets of the organization. And if that's communicated clearly, almost everyone will be willing to go along because they want that. Application developers, enterprise architects, database administrators, whoever they are, they want secure systems. Now, it needs to be done in a thoughtful way so that it's not prohibitive to them accomplishing their goals. But as long as there's a compromise and a way to reach the desired end state, everything works out well. And the security organization is actually valued rather than being looked at in a negative light. A key concept to keep in mind, and this is universal, it's not just within this domain, although it is quite valuable in this domain, is that you need to inform people and educate them, especially higher level management, so that they can make appropriate decisions. It's about informed decisions, understanding the risks that are associated with the decision or the risks that are associated with the lack of a decision. Sometimes that is as compelling as the other. And so there comes out of that some kind of controls and best practices that organizations typically follow. So the key takeaway here is that part of your job as a security personnel is to educate the stakeholders, including senior management and so on, as to the potential risks that are associated with choices and make sure that the organization is taking the appropriate level risk for the organization. Some organizations are more risk adverse than others. That means that what might be acceptable for one company may not be for someone else, potentially because they're in different lines of business, or it may be just the nature of the organization. Your role is not to make that decision for them, it's to inform them and tell them, here's what's going to happen if you do this. This is what's going to happen if you do this. And which one of these is acceptable? They'll both reach your goal, but this one potentially has higher risk and maybe higher reward, but still, is that risk acceptable? So it's making sure that people understand why they should decide a certain thing, not just making that decision for them and trying to dictate rather than influence. Along those lines, the Open Web Application Security Project has kind of distilled down several of the most well-known security principles, and these are kind of universal. They'll span lots of different courses you'll take while you're studying security in an organization like University of the Cumberlands. A common one is applied defense in depth. So basically what that implies is that rather than having a single layer of security, have multiple layers. Think of it like an onion, that once you get past the outermost layer, you're not into the middle of the thing. Potentially, maybe think about it, an onion or something with multiple layers that has something really good in the middle that you're trying to get to. So you, as somebody that's trying to get into the system, has to get past multiple layers in order to reach your goal, not just a single sort of you access some network and you're in. There's got to be multiple layers kind of preventing you from getting someplace you shouldn't be. So you also want a positive security model. So basically fail-safe defaults, and you want to minimize your attack surface. So with that, you don't want it to be that you get in by default. You don't get in by default. You only get in if you should get in. So and if something bad happens, you don't get in. So if there's an unknown error, so in the case of fail securely, if for some reason your authentication process has a problem, you would not want that to allow you to have access to something. The same thing if your application servers for some reason had a problem. You wouldn't want that to be a means that allowed somebody to potentially get to a database server or whatever it might be. Because in the past, that's what would happen essentially. If you think about things like a buffer overflow, that sort of attack is about creating a failure scenario in a lot of ways. And so if you don't fail securely, then it is potentially successful. Running with least privilege, and the least privilege model is also a universal sort of thing that you'll hear in lots of different courses. It's more challenging to only allow the permissions that are necessary for somebody to complete their task, but it is more desirable. It's easy to say everybody's an admin and they can do whatever they want to do, and applications just work magically if you do that. It's much harder to go through and figure out what is the absolute least amount of security that you can give an identity or a principal and still be successful and it still work. Um, Security by obscurity, which is not really security at all, is not a great idea either. Your basic idea there is that, well, you can't find this URL, so it's secure. People have a way of finding things that they shouldn't find. The same thing would be, well, nobody would ever find this IP address or this port or whatever it might be. And people scan for ports and they scan for IP addresses. So not a great idea. And it's not secure at all. You want to keep things as simple as can be done to meet the desired goals. That's going to be true of security. That's going to be true of application architecture. It's going to be true of application development, any of that stuff. Simpler is better almost every single time because people need to understand it and need to be able to figure out why it's doing what it's doing. You want to detect intrusion and, in fact, as soon as possible, intervene. And that implies typically near real-time processing of some sort. So you don't do some sort of analysis of your firewall activity in batch once a week or something, because at the point that you would determine that something had been going on, it'd be far too late. So you want to detect it as it's occurring, and you want to keep track of the fact that it is occurring as well. And don't trust infrastructure is kind of the same thing as don't trust physical security. Don't assume that that's going to just take care of it. You want to have a layer of software, especially as organizations move to the cloud, that takes care of things like the security sort of integration and activities. And lastly, you want to make sure you have, lastly on this page anyway, you want to have secure defaults. So you don't want it to be such that the standard sort of thing that occurs is a bad thing. So for example, if you're creating a user inside of a domain, you wouldn't want that domain to be created by default with elevated permissions. Instead, you would want it to be a relatively secure or relatively minimal sort of thing so that they can't do very much without getting additional permissions. Moving on to section 1.3, thinking about applying security pretty much to any system, and especially to systems inside of an organization that may be new. Maybe it's a new company, or maybe it's something that's expanding into a different world. So there's some pretty good concepts inside of this slide to pull through. One thing to understand is that security can change over time. So the amount of security that's going to be appropriate and applied early on in a development isn't necessarily appropriate later on. That being said, one doesn't want to wait to the very end of a project to start thinking about security and thinking about making sure that things are being done in an appropriate way. It's something that should be considered all along the life cycle, but sometimes it's very challenging if you have, say, one solution out there to invest a ton of time and money in creating a system, because you don't necessarily get to do this reaping economies of scale. That's an important concept. It's about spreading out the cost of a particular system across multiple consumers or users of that system so that it becomes more economical for everybody to be using it. So that's where you'll need common architectures to facilitate that later on. So whenever you're designing systems in general and thinking about it from a security perspective, one needs to design it in such a way that later on additional security mechanisms can be put in place to handle the fact that there will be new things being built and extended along the way. You also, though, want to keep things as simple as you can. So again, minimize complexity, plan for the future by being simple and open, but yet making sure that it is secure enough to meet the needs at the time that you're dealing with. And so a key thing to think about is almost every size and type of system will have some security needs. That's a very powerful statement, but it's something that people don't always think about. Pretty much every system, if you really take a step back, um, needs some means of authentication, access to something. Even if you're writing something that's a very simple sort of command line, potentially utility that's going to go out and connect to a database, process some records, and then update something. Even something simple like that needs to know how to authenticate. And if you do so, you can do it several ways. One is going to be relatively secure and be a good practice to follow. The other, not so secure, like putting usernames and passwords inside of the source code itself, and then potentially forgetting that you put it in there and not changing those credentials and somebody finding it later on. So there's also, and this has happened a lot over the years, I've written a lot of things that were supposed to be temporary and disposable that have lived a very long life. So sometimes these one-off utilities sometimes turn into bigger things over time. You start off by writing a very simple application that does one particular thing that's necessary, and then over time somebody else finds out what you've written and they say, hey, could you add this to it? And you extend it further, and before you know it, it becomes a mission critical application. So when you're talking about complex business systems, there's typically you're going to know what the requirements are at the beginning. Sometimes, although sometimes those requirements will be incredibly vague and nebulous. The system should be secure or something that's worthless like that. But sometimes we know more about the more complex stuff ahead of time. So you want to manage the complexity uh, and make sure that you're not making the systems more complex than need be. So it's almost that Occam's razor concept of the simplest solution is probably the best solution. There are exceptions, there always are, but uh, whenever you're looking into how complex is too complex, you want to make sure that it's meeting the needs and it's doing so in an elegant and simple way. And then whenever you're going to decide if you need to do an architectural risk assessment, you'll come up with the threat model and figure out some key questions like how are things going to be deployed? What will be the distribution? So where's the thing going to run? What language and execution environment will it run in? And so on. So those are all going to be factors that go into the decision around when you need to do an in-depth analysis of the architecture. Also, you'll consider things like size and how important it is to the business, and how much money can be spent. And there's lots of factors that go into it. It's very rarely a very simple sort of decision. But if you've got something that's not all that important to the organization, that if it were to become compromised, the data that it's dealing with is not necessarily all that important, or maybe it's been partitioned in such a way that it really has no value at all unless you know what to do with it, then it's going to be very difficult to create a complex security architecture around that. Um, and so whenever you're talking about figuring out what systems you're going to be dealing with, and so on, you want to be very precise and you want to be very clear, um, so that you know exactly which ones you're talking about and which ones are going to be assessed and where the scope of things lie. And there's some things that um, some organizations are willing to take unknown risks. Um, Depending upon what's involved. And so don't assume that you have to know all the answers to every question. It's like if you have an illness, depending upon what you think that illness might be, sometimes there's no real point in doing a whole bunch of tests. In fact, a lot of times if you have a certain set of symptoms, rather than doing any test at all, the doctors will just prescribe maybe an antibiotic that's a broad spectrum antibiotic that's likely to solve whatever might be the problem. And then it's the same sort of concept here, is that some organizations don't necessarily need to know everything that possibly could go wrong within a certain system, especially if they can mitigate that risk in some other fashion. So in the conclusion of chapter one, we get a pretty good definition of what information assurance is and when we achieve it. And it's whenever you're applying um, security principles and concepts and application security services and so on in a way that you can manage and protect against attacks. And you're basically um, balancing the risks that an organization is willing to take in order for them to do their business that they need to do. And so that means that you're going to want to make sure that you're um, incorporating some sort of protection mechanisms, obviously, and you want to be able to tell when you're being attacked, right? Because otherwise, how would you know what you need to do to mitigate it? You certainly would want to know if you've been an attack has been successful or not. Because if an attack has been successful, then you need to be doing things like remediation and fixing things and recovering. So I guess taking a step back about the whole topic that we're talking about here, because your text and what we're talking about on these slides is around securing systems. In order to do that, you're very much dealing with the realm of integration. And integration is always a challenging topic. Systems need to talk to other systems, and we have various controls where we've done that. Historically, long ago, we would rely on physical security. You would literally, we have an expression of put all of your eggs in one basket. And what that means is take all of the stuff that is of value to them, put them all together. And we would do that in a building um, on the company's campus and call it a data center. And you would put everything inside of there, and you wouldn't let things in and out of there without a lot of discussion. And the assumption would be then that if it's inside there, it's safe and it's okay. We learned over time that wasn't necessarily the case, and relying on things like physical security were a bad idea, in part because organizations are sometimes compromised. You may have a disgruntled employee that plugs something into your network that suddenly circumvents all of that protection, like a Wi-Fi router. So all of a sudden, somebody outside of the building, outside of your physical controls, has access to stuff. And also we had this concept of the cloud that came along. So all of a sudden we had to start thinking about integration in a secure fashion whenever you couldn't rely on physical security and you couldn't rely on certain networks being connected and so on. That never really worked all that great anyway, because you were relying on somebody configuring everything correctly, such as plugging the right network into the right port. And oftentimes you would think perhaps that a database server was on a certain subnet or a certain network where it was isolated. In reality, it might not have been because it was installed incorrectly. So the whole point of all that discussion is that we need to make sure that there is a good architecture in place to address security in a holistic sort of way. And that's what we'll be talking about through this course, is how to secure these systems in a thoughtful, balancing the needs of the organization to access their systems, their data, and so on in a way that is in line with the amount of risk that they're willing to take to accomplish what it is that the business objectives have specified. So you can't just say, well, we're not going to have anybody accessing the database, because people need to access the database to do their jobs. And with that, I will conclude our discussion of chapter one. As always, if you have any questions, feel free to reach out to me, send an email, message, whatever mechanism that you can use. I'll get back with you as soon as I can. Stay safe, and I'll talk with you soon.